Hi guys, we are on to lesson 6 of the mole and calculations topic of Nat 5 chemistry. This is going to be some mole equation calculations. Now these are a little bit different from what we've done before, and we are going to show you two different methods to solve these questions. Whichever method you choose, stick with. Do not go between the two methods. We're only showing you two methods because some people prefer to use the triangles and other people prefer to use the mole ratio method. So like always, we have some starter questions. One is write down the equation for calculating the moles of a solid compound. 2 is calculate the gram formula mass for carbon tetrachloride. And 3 is what is concentration measured in. So pause the video, attempt the questions, and then unpause and see the answers. So equation for calculating moles for solids is number of moles equals mass over gram formula mass. Gram formula mass of carbon tetrachloride is 154 grams. You should have 12 for carbon plus 4 times 35.5. What is concentration measured in? It is measured in moles per litre, which you can just see there. So we are going to calculate masses for unknowns in chemical equations. So we're going to have something on the other side of the equation that we need to calculate, and we're going to use the number of moles to go between the left-hand side of the equation and the right-hand side of the equation. We are going to be able to calculate the masses needed to react or the mass produced in any reaction that you are given. So if a chemist knows that the balanced chemical equation for a reaction and at least one mass, it's possible for us to calculate how much product we're going to make. So if the reaction starts with 1 mole of carbon, it will need to react this with 2 moles of chlorine to produce 1 mole of carbon tetrachloride. Okay, that just information comes from our balancing equations knowledge. If we have C plus Cl, we're going to multiply the Cl by 2 to get 4 on the right hand side. So we know that already. Why is that important? Because it's going to help us calculate the mass. So the question says, calculate the mass of hydrogen produced by dissolving 0.2 grams of magnesium in excess sulfuric acid solution. So, first of all, we need to balance the equation. 2, identify which compounds the question is asking about. That's why we have highlighted some parts. And 3, identify which compound the question has given a mass for. So balancing the equation is extremely important because if we don't balance the equation correctly, then we're going to get the next part of the question wrong. So make sure that you are using your balancing skills and balancing the equations accurately. So the equation, from just by looking at it as balanced, identify which compounds the question is asking about. That's what our ticks is for. Now you can tick them or you can circle them. It's completely up to you. But we are looking at magnesium and hydrogen. The question says mass of hydrogen. It says 0.2 grams of magnesium, okay? It only tells you that there is excess acid, so we don't need to worry about that. That just means there is plenty of acid to react with all of the magnesium. So, what we can do this time is we can use a triangle on both sides. We have been given a mass of magnesium which is 0.2, and we know the formula mass for magnesium is 24.3 or 24.5 if you're using the Nat 5 data booklet. We know that the formula mass for hydrogen on the other side is 2 grams, and we want to calculate the mass of hydrogen. So what we're going to need to do here is we're going to need to work out the number of moles that we have of magnesium. If 1 mole of magnesium here produces 1 mole of hydrogen on the other side, then we can simply transfer that number over to the next triangle. So let's calculate our number of moles of magnesium. We have 0.2 divided by 24.3, which gives us 0.00823. Now this is a number that we want to keep in our calculator. We don't want to round our answers until the very last step. So our number of moles is going to be the same number on both sides. How do we know that? Because we have 1 mole of magnesium and 1 mole of hydrogen. So if we have 0.008 moles of magnesium is going to produce 0.00823 moles of hydrogen. Okay, the mole ratio is a 1-to-1, which means we can copy it over directly. So now we know 2 parts of the triangle for hydrogen. All that's left to do is figure out the mass. Now the mass equals number of moles times formula mass. We're going to have 0.00823 times 2, which gives us 0.0165 grams of hydrogen. So that's how you use the 2 triangles to get an answer for that question. The second way to do it is by simply using the mole ratios. So still similar steps. Balance the equation, identify which compounds the question is asking about. Those are always your first 2 steps when you're doing calculations. Step 3 is a little bit different in this method. It is identifying the mole ratio. So, hydrogen is ticked, magnesium is ticked. Those are the 2 things we're interested in. We can go straight to saying this is our mole ratio. 1 mole of magnesium produces 1 mole of hydrogen. How much does 1 mole of magnesium weigh? It's 24 grams. How much does 1 mole of hydrogen weigh? It's 2 grams. We don't have 24 grams of magnesium. We only have 0.2 grams. So if we scale down to 0.2, we can then work out how much hydrogen is produced on the other side. And the way to do that is to multiply your corners, so multiply the 2 and the 0.2 together, and divide by the number that's left. So multiply your diagonals and divide by the corner that's left. So that will be 2 times 0.2, and whatever the answer to that is, divide it by 24. You end up with 0.0167 grams. The reason that is different to the previous answer is because we've just rounded this to 24 here. It should be 24.3 or 24.5. So here is another example. First of all, using the triangles, and then we're going to use the mole ratio example. Now make sure when you are writing these out, the method that you understand the best, use that one and completely ignore the other one. So the question asks, calculate the mass of iron produced by reduction of 6.4 grams of iron 3 oxide with carbon monoxide. So step 1 is to balance the equation. Step 2, identify what compounds the question is asking about. And 3, identify which compound the question has given a mass for. In other words, do a triangle at each side of the equation. So the equation has had to be balanced. Let's tick our compounds that we're looking for. So iron, we're asked to calculate the mass of iron, and we are given the mass of iron 3 oxide. So those are the 2 things that we are interested in. Our triangles, let's fill them in. We have 6.4 grams, that's our mass of iron 3 oxide, and our formula mass we can calculate as 159.6. On the other side, we have just Fe, which is iron. The formula mass for iron is 55.8. So, let's work out our number of moles. We have number of moles equals mass divided by GFM. Our mass of iron oxide is 6.4 and the GFM is 159.6. That gives us a total number of moles of 0.0401. Now this time we don't have a 1-to-1 mole ratio, we have a 1-to-2. That means whatever the number of moles we've calculated on the left, we have to double. So 1 iron oxide to 2 irons is 1-to-2 mole ratio. So 0.0401 becomes 0.0802. So our number of moles then we can add into our triangle and we can calculate the mass of iron. So M for mass equals N, number of moles, times GFM. We have 0.0802 times 55.8 to give us a mass of 4.48 grams. Method 2, following the same pattern as we have before. We have balancing the equation step, identifying the compounds the question is looking for, and then finally doing the mole ratio and working it out that way. So balance the equation first of all, identify the compounds, so we've got Fe2O3 and Fe, same as before, but the next step is the mole ratio. So 1 mole of iron oxide produces 2 moles of iron. The mass of 1 mole of iron oxide is 160, produces 2 moles of iron. If iron's gram formula mass is 56, we have 2 moles, so we have to multiply it by 2, and we end up with 112 grams of iron. We have rounded some of the values here just to make it a little bit easier. So we don't have 160 grams of iron oxide, we have 6.4. So if 160 produces 112, 6.4 is going to produce 6.4 times 112, so we're timesing the diagonal values and dividing by the corner that we have left, which is 160. So if we do that calculation, we end up with 4.48 grams. So it doesn't matter what method you use, both of the methods end up with the same value at the end anyway. So you are going to practice some questions on this in class and then swap jotters and mark it at the end. Hopefully, we are able to calculate the masses needed to react or the mass produced in a reaction by doing either the triangle method or the mole ratio method. As I said, pick the method that is most simplistic to you and easy to use and completely ignore the other one. Nobody should be trying to attempt both methods. Pick one and stick with it. So that was lesson 6, mole equation calculations.